All right, hello again, everyone. I know the news can get heavy at times, and spending your days and nights at home can get a little weary, but I have some good news. Today is National Fun at Work Day. So 3 cheers, everyone. I hope you're all settled in, because we've got a very interesting discussion planned today. We're going to talk about the burgeoning interest in electrification in new construction. We'll sort through the hype and reality for builders. Are there opportunities and/or obstacles in electrification? We'll also explore what's driving the interest in electrification. Where is it currently happening? Where will it happen next? And where is it unlikely to take off? Also, what are the implications for utilities and manufacturers? We've got 2 guests to navigate through this topic. Our first guest is Steve Byers, CEO of Energy Logic, the Colorado-based company that serves clients with a wide variety of services and from inspections to consulting to data analytics and software. A graduate of the Air Force Academy and South Face Institute alumni, he's worked in sustainability since 1993 and runs Energy Logic with his wife of many years, Win Maggi, along with all the other talented people at Energy Logic. And one of those talented people is Nathan Carr. After graduating with a master's degree in building science from Appalachian State University, Nathan came to the Denver metro area to work for a high-performance production home builder. He just recently arrived at Energy Logic and brings his experiences and time spent working for said builder to help understand what is important to builders and what information they need to get the job done. As business development manager, Nathan works with builders of all sizes to help find areas for improvement and opportunities to grow closer to the idea that all homes can be efficient, healthy, and local. He has presented on building science, renewable energy, and home builder quality assurance throughout the country, including sessions at ResNet, EVA, and IBS. Now, before we get into our discussion about electrification, I need to let you know that this webinar is being brought to you by PowerShift by NV Energy. You can never save too much energy or money. That's why NV Energy has introduced PowerShift to help its residential and business customers conserve even more energy and save money on their power bills. PowerShift by NV Energy is also about providing you with excellent customer service. It's your one-stop shop to find all the energy-efficient products and services to help you boost your bottom line, along with convenient ways to manage your account. PowerShift Energy Advisors are dedicated to working side by side with business customers to discuss their needs and to find energy efficiency solutions that save money. Plus, their Business Solutions Center is the place to go to discuss your bill payments and account-related questions. For more information, please visit nvenergy.com/PowerShift. During the course of today's presentation, you can submit questions for Steve and Nathan. Simply use the questions box on the right side of your screen. I'll review those questions and pose them to the guys during the Q&A time set aside after their presentation. Now, I have to say I consider Steve a friend, and it's my honor to welcome you to the webinar series, Steve.
Thanks a ton, Mike. Let me make sure everybody can hear me. Mike, are you hearing me?
I am hearing you loud and clear, sir.
Fantastic. So I'd like to jump right into the deck. There we go. So first, I'd like to offer my welcome and thanks to our sponsor. As Mike just told you, PowerShift from NV Energy. I'd like to thank all of you attendees taking time out of your day to join us here for this discussion. I'd like to, of course, thank Green Builder Media for making all this possible and putting it on. I'd also like to say that it being April 1st, we had this, when we first conceived of this and we're talking about it, we were planning on doing a, really humorous April Fool's Day sort of thing to kick it off. And frankly, that just didn't feel appropriate to us, so we're not doing that. So there are no April Fool's jokes or anything like that in the presentation. But I would also lastly like to offer thanks to those who are not with us and wouldn't be anyway, but all the first responders that are out there dealing with the world today, and my deepest thanks to what they're doing every day right now. So first thing to kick us off, we've got a couple of polls that I saw the notice flash up that the polls are open, and there are 2 polls there. They're categorized. You can't do open-ended poll questions on this platform, so we put a few options out there, and if it doesn't fit you, apologize. And then so what you do and where you are from by climate zone. We'll leave those open here for a few minutes while we roll along another slide or so, and then I'll probably break away, ask Mary to come back and give us a little insight into what the polls told us. I don't see that here, which would be distracting anyway. So let's see, let me go to the next slide now. So what we're going to do today is cover a broad overview of the electrification trend. We're going to dive in, reasonably well to what the climate impacts are and why they really matter. Why electrification really matters for our work in trying to alter climate change. We're going to hit some builder-centric topics, and this will tend to be new construction focused, but we're going to recognition to the breadth of what's possible in electrification for sure, and touch on some innovations and applications. We've assumed a broad audience would be on, from true electrification aficionados to people who are, for whom it's a relatively new topic. So just so people understand the scope of what we're going to do today. And so I think people probably should have had time now to have looked at the poll and answered the questions. And Mary, could you jump in and tell us something about what they say?
Sure, Steve. Can you see the screen now? I'm sharing the results, but maybe as a panelist you can't see, but we've got...
I can't see them,
Okay, so builder, we got 25% of attendees are builders, 14% architect, 33% utility, 19% rater, and 8% manufacturer. And
cool.
Then as far as the climate zones, we have 10% in C1, C2, 27% C3, C4, 27% C5, C6, 17% C7, C8, 20% NA.
Okay.
Back to
Perfect.
you. Yep.
Yes. Thank you very much. So what's great about that from on both polls, from my perspective, is we do have a really broad audience in terms of representation of different things that we're all doing, and the climate zones are all pretty well represented. So that's really fabulous from my perspective. Okay, so next. So what is it? I think that there may be some people may have a perception that it's a fad, and it's definitely not a fad. It's a trend. There's no question about that in my mind. But very distinctly, what we're talking about is taking fossil fuels away from combusting them on site in the home, and having that be the combustion all happen at a power plant or from renewables, and that could come from a variety of places, obviously. And as I said, while our world at Energy Logic definitely focuses primarily on new construction, electrification applies to all structures, all the way from residential to industrial applications, and from new build to retrofit. So really, from everything that I believe and understand, we're talking about the ability, the drive to electrify every building on the planet, really, ultimately. And hopefully this will be something new to many of you. Electrification is, however, a soft trend, and a guy that I read and follow, his name is Daniel Burris. Daniel Burris is a pretty well-known futurist, and he defines trends in 2 categories: soft trends and hard trends. And we have a very unfortunate, perfect example of a soft trend right now. I'm sure that many of you, like me, have been daily looking at charts of the growth of the COVID-19 illness, and seeing how and you see those charts, you see the reported cases and different ways to be counted aside, yes. And then you see all the different modeling that says how we can flatten the curve, for example. Well, that tells you right there what a soft trend is. A soft trend is a trend in which something, we can change it, something exogenous can change that curve. They are not hard trends. Hard trends are one of the best examples, or the easiest way to describe hard trends is demographic trends. So you can look at a demographic trend line, and it's, you know, it's not going to change. You know, the United States is aging, the planet is aging, for example. You can look at any one country's demographic, you know, mix and see that those are things that are not going to change, you know, short of something truly catastrophic, which hopefully this is not. So when you think about electrification through that lens, I would contend that it is a soft trend, because there are things that you could envision, that you could imagine, that could change it without getting into you know, deep debate about what those might be, or discussion about what those might be. I offer that up as just another lens to look at it through. So again, not being a fad, being a trend, it's a chart, and I try to put make sure that every place where I've used a chart from a report, etc., out there in the great wide world of the internet, that the organization that put it out there is either on the slide or I tagged it in there so you know where they came from. So this came from EIA, Energy Information Agency, and yeah, this gives you a pretty clear picture. This starts in 2005, only goes to 2015 because this data is primarily pulled from the Residential Energy Consumption Survey. And of course, we don't have a 2020 version yet, so this data stops there. But you could see across every climate zone, you know, the number of homes that are all electric has been steadily rising. It's, as many of you probably know, the South has, you know, the largest percentage of homes that are electric, dropping down to the Northeast. But in every case, you see the lines rising, and you know, that makes for a good trend line. So that's another reason why it's really nice we've got a broad mix of people on the call from all the climate zones, and this is broken up by census regions, not climate zones, but you can fill in the blanks. Okay, so while our discussion is not going to, apologize, utility folks, it's not going to really focus on grid benefits. There are tremendous grid benefits out there. Flexibility in the grid, the way that when you have a home that's fully electric, the capacity of any utility, via technology, of course, to work with that home as, you know, one small piece of their grid, that, you know, appliances can be turned off and on, etc. When you integrate smart IoT and smart devices into the mix, it gives greater grid flexibility, grid resilience. And then, of course, electric vehicles, when we work them into the mix, another piece of the puzzle. And then lastly, rate design can have a huge impact on everything that we're going to be discussing throughout the course of, you know, our discussion on electrification. I'd like to reference yesterday, there was a webinar put on by NEEP, Northeast Energy Efficiency Partnerships. Great webinar that went into, you know, a great example from Burlington in Vermont, Burlington Electric Department. Very inspiring stuff that they are doing, impressive. And I'm pretty sure, I didn't confirm, sorry, I was getting this together, that webinar is available. I'm not positive about that, but it should be. And so lots of resources from NEEP, which I'll reference again, actually, here in a couple of minutes.
And Steve, this is Nathan real quick, just jumping in on this. In our own backyard, NREL, the National Renewable Energy Lab, is doing some really cutting edge research around grid connected devices. Really fascinating, and I would be willing to share some resources from them as well.
Fantastic, yes, and appreciate that, Nathan. And we're going to you're going to see some things from NREL and from a variety of other sources too as we go through, and I'll list them all at the end and offer them my thanks as well for the work that they've done. Okay, so the source mix matters a ton in terms of the climate impact that we're going to have when we look at the grid as a whole. So, you know, and I won't read everything to you. You guys can read as well as I can. We have a lot of homes burning a lot of fossil fuels, and primarily we're talking about, you know, what they're doing it for is heating and water heating. Then there are some other ancillary, you know, uses, but those are the big ones, of course. Those are the heavy hitters. And in putting this together, you know, the numbers sort of boggle the mind sometimes. You know, that it generates 560 million tons of CO. That should say CO2. Sorry about that. Each year, somehow I dropped a number out there. A tenth of all total U.S. emissions, and that's a staggering number. In order to meet our climate goals, we're going to have to eliminate nearly or as close to eliminate that on-site burning of fossil fuel. There's really not much way around it. So writ large, if we, you know, to give a context or a framework for how we might think about this, we think about electrifying structures. And really, again, to emphasize, this is about space heating and water heating primarily, but we also have cooking and clothes drying. And again, there are some other, you know, small, much smaller, but it's heating, space heating and water heating are the big drivers. So we electrify homes. In doing that, then we green the grid. And that comes through primarily renewables, which we know most of us would be hoping for: more renewables, more wind, more solar, more other cutting edge and innovative renewables. And, you know, combined cycle gas turbines, where they don't exist, that's part of the equation too. And then, you know, potentially carbon capture on the other end, which we're not going to touch on at all in the rest of this discussion, but that's another piece of the overall potential. So again, I said I'd reference NEAP. In looking at stuff prior to even knowing about the webinar that they put on yesterday, I saw this graphic that they had, which also encapsulates it really well. And this comes specifically from their goals, where I pulled it out and blew it up because it's too small to read, but, you know, combining efficiency plus renewables with strategic electrification, their objective is to drive to an 80% reduction in greenhouse gas emissions by 2050. You know, and that's impressive. And of course, there's tons of stuff on neep.org and a variety of other places too. I just, you know, particularly called them out since I saw this yesterday. So here's a graphic that I pulled out of a report from EPRI that, you know, I'll give everybody a chance to absorb what's being said here. You start with the source fuel, so in this, you know, natural gas. And then you take the upper pathway, and this is an electric pathway. The lower pathway is the non-electric pathway. You know, you've got how efficient is the power plant, how much transmission, T&D is transmission and distribution, what's the loss? There is a loss, it has to be accounted for, and all the calculations to be done. It's the efficiency of the appliance at the end. And in this case, we're looking at, this example comes from a home in Atlanta, 2,000 square feet, 4,300 heating degree days. And then the bottom path, you've got the source fuel burned on site by a 90% efficient furnace. And, you know, when you run the numbers all out, what you end up with is that it's roughly, after you take in primary energy, et cetera, 1.6 times as much carbon is produced in the non-electric pathway. That's a meaningful difference, obviously, and this is where we're trying to go. And that's assuming a 90% furnace, and there's obviously a lot more of them out there that are not 90%. And when we're talking about the time when it's most rational, feasible, et cetera, to replace units, they're unlikely to be 90%. So again, back to the source mix, more charts from EIA, and you'll see, I'll give you a chance to look at particularly focusing on the chart in the middle, the electricity generation from selected fuels chart, where you see, the left-hand side of the chart is 2010, dotted line roughly where we are, and then it extends out to 2050. And this is from the EIA, which has a particular perspective and agenda that is quite conservative. We're going to have to, I will preface by saying, we're going to have to do a lot better than that to get to where we need to be from a climate impact perspective and what we're trying to achieve. I'm assuming a broad-based we here as I say that. And it can't just be the grid. If we're getting rid of, if we want to reach deep carbonization goals, which RMI is defining as 75% reduction, getting rid of furnaces and water heaters, yes, the things we're going to focus on primarily in this discussion are really technology swap outs, if you will. We're not going to go into building envelope topics. That's a huge piece of the overall puzzle, is getting better envelopes, because whether it's electric or non-electric, if you have a crappy building envelope, we're not going to get to where we need to be. So just straight, technology swap outs won't do the whole trick in the long run. We're going to have to focus on envelopes as well. Obviously, envelopes in existing structures, much tougher to deal with. On the new construction side, we still got a long way to go as well, of course. Codes are getting better all the time, definitely helping. We've got market drivers. Who knows what comes out of the other end of the situation that we're in now in terms of, are we going to have retrenchment on goals because there's going to be a, understandable desire to get back to whatever normal was? I don't know, and I'm not sure anybody could, but I'm sure that many of us are thinking and worrying about that question right now. I'd like to hope that we won't have a massive retrenchment that just says, well, let's burn, baby, burn, to use a trite term possibly, to get back to where we were. But maybe there's opportunities out there and what's happening now where we see another pathway forward. So hopefully, hope springs eternal, at least maybe for me. So another graphic that gives you a picture of what this all means from RMI. On the left, you see 2015, and then the second bar in is decarbonizing power generation, and then you see the fossil fuel use in buildings in the light green on top of that. And then if you electrify buildings, you get 38%, and then the furthest most is something we won't touch on again because it gets into transportation and industry, but electrifying cars, trucks, and half of industry as well. So different parts of the keys, how we're going to get to the overall carbon reduction that we're looking for. So again, I won't belabor this further, but the status quo is not going to cut it. If you, again, I pulled a graphic from EIA, and this one's quite disturbing to me, and it gets small on the bottom. That's why I'm going to describe it a bit. But the line that goes up in the middle, right at where we are, where we see this declining curve, and then it says that resumes modest growth. Carbon dioxide emissions resume modest growth in the 2030s, and that's distressing to think that that's what the reference case. I mean, it is the reference case, and I understand that, but that is not going to cut it. That is not where we need to be, and we're going to have to do a lot better than the EIA is assuming that we are going to do or that we can do. Let me give you another set of graphics that perhaps paint a picture that's a bit more like what we want to see. And these come from EPRI. And I'm not going to go into a long description of what their categories are here. Conservative and reference case are roughly the same lines, so you can think of those as roughly equivalent to the status quo. A progressive pathway and a transformational pathway in terms of Carbon intensity on electric generation on the side, and carbon emissions obviously closely related on the right side. This is much closer to what we're going to have to achieve. And when we talk about electrifying structures, really we're talking about the progressive and the transformational pathway. Those are the pathways we need to be on to get to the carbon objectives that we need to see. And on the climate impact part, it's really important, and I think that we sometimes, you know, I'll just speak for myself. You know, I'm in the silo of working in new construction, new build all the time. So my world is not the utility world. But when, you know, so I think about structure and like, what are we doing in that structure? How are we driving to zero, et cetera? And then I tend to forget that changes made to the grid have the biggest impact. So a change in the efficiency of the grid or the fuel, the portfolio mix on the grid side, those are massive impacts. Every change on the grid side impacts all the downstream users. That's enormous. And you think about, you know, changing one by one, you know, electrifying house by house. Yes, that's the work that rebuilding professionals need to do. But changes on the grid side, again, not my world, massive changes. Again, these are charts from the EIA. Again, we're going to have to do better than these charts reference, but you know, it gives you maybe a sense of, as we change those mixes, the massive impact that the grid side has on where we're trying to go. And with that, I'm going to transfer to Nathan.
Wonderful, wonderful. Thank you, Steve, for kind of giving a really great overview of where we need to go. Where I'm going to take us is really talking about what are the possibilities right now? What changes can builders make right now? And then also some of the big innovations that we are seeing. So really first starting off and talking about, in my opinion and my experience, what are some of the biggest things that I see that are going to be great about electrification for builders? And then some of the things that builders are going to have to figure out how to overcome. I have these listed as pros and cons, but pros and cons makes it seem like that it's good and bad, but it's really what's good for us right now and what's standing in our way. So Steve, could you go to the next slide, please? Wonderful. So one of the best things that I've seen, and this is coming from real experience where we truly tried to run the numbers here in Denver around what we could save in infrastructure costs by transitioning a planned community from what was planned for both gas and electric to all electric. And what we were really able to find is that it was well over $2,000 a home that we could save by not deciding to go for gas. And what we had found is that our added costs were still a bit higher than that, but this started to bring it back down into a more reasonable upcharge when we're trying to build homes that are higher performance, but also competitive to the market. One of the things that I want to bring up in relation to this is that, you know, looking for ways to make change now is one of my big focuses. And so trying to decide, is there a mid-ground? From what we had seen, so around $1,000 to get gas from the street to the home and then piped throughout the home so that it could be used by the buyer. So what we had seen, and this came from a progressive builder, this inspiration came from a progressive builder in Arizona, that they had planned for all electric, planned the homes for all electric, but one of the options that they brought up was they wanted to maintain the competitiveness and still be able to sell to buyers who were interested in gas. So while they did gas infrastructure to the whole community, one of the pieces that they were able to do is the first gas appliance that any buyer wanted to install came with a pretty significant upcharge to handle that home by home cost. So that I think was a really innovative piece. Steve, next slide, please. So I'm going to switch back and forth between some of the benefits and then some of the issues to be resolved. And so the next one is really looking at existing homes. Looking at older homes in the Denver market, we can see anywhere from 100 to 150 amp service, which when everything is gas, for cooking, for heating, for water heating, it works out pretty well. But if you transition that to a heat pump and a heat pump water heater, you can very easily end up overloading the service. So this is something where truly understanding those costs and understanding what the true cost for electrification is going to take is going to be important, and finding really the best solution, working with your local utility to find the best solution to get a bigger electric service to the home without adding so much cost that it becomes unrealistic for a typical buyer to upgrade. Next slide, thank you. The next piece, the pros and cons, one of the things that I mentioned, I truly believe that with all electric, you are going to end up with a more comfortable home. Some research that came from a great building scientist, Achilles Kariogis, formerly of Owens Corning, now at NREL, did some great research and modeling on comfort. And one of his conclusions that he really saw was that until you can get room by room control, there are always going to be uncomfortable parts of the home. And so trying to find ways to counteract that. Of course, the first thing that came to my mind was that mini splits were a very viable option. But even when you look at traditional ducted systems, when we see heat pumps installed in our market, they typically end up being equipment that has both a variable speed fan and a variable speed compressor. So you're really able to match loads very well and really keep that home more comfortable than a typical on-off or a PSC motor. So you're really trading off a higher cost, but if you can engage your buyers and engage them in a conversation around comfort, they might be willing to pay for that higher cost. Next slide, please. Yep. One of the other big incentives that we've seen both in Colorado and just across the country, because of the possibility for greater grid flexibility and greater opportunity to shift loads, we're seeing much higher incentives for electric equipment than we are for natural gas equipment. Also relates back to just the cost of natural gas has continued to drop, continue to drop even more in our current climate. So seeing more opportunities for electric to take advantage of these incentives. Some of the larger incentives that I've seen, seeing as much as $2,500 for replacing a furnace with a heat pump. Significant money on the table. I believe in Colorado, we're seeing as much as $400 for a Wi-Fi enabled heat pump water heater, if the buyer is also willing to enroll in a load shifting program. So the incentives are out there, and they are a great opportunity for builders to provide their homeowners with a traditional experience, but also be able to save them money in the process. Next slide, please. Then probably the biggest thing to overcome is going to be buyer resistance, whether that is an aesthetic or an experience that they are looking for. In Colorado, we see a lot of gas. Gas is kind of the standard for us, but I'm originally from the Southeast, where thank you TVA and thank you for the electrification of the South, electric became very common, and having gas is seen as a sign of luxury. I think that sentiment has continued throughout the United States, and being able to have a gas stove or a gas fireplace, especially in Colorado, is a very difficult mindset to overcome. But there are, I think, opportunities out there, and we're going to talk a little bit more about those moving on. One of the other pieces, just to be careful about, a heat pump typically will put out a lower air temperature than a gas furnace. So if buyers are accustomed to standing directly in the way of a vent as it's blowing out hot air, they may feel like their air is not warm enough, where furnaces are trying to put out up to 120-degree air. Heat pumps are not going to be able to put out that high of a temperature, and getting them to understand that yes, their house is going to be warm, but they're not going to have that same feeling from gas of standing right in the way. And then it also just means being a little bit more aware on your HVAC design, making sure that air is not blowing directly on top of people. And then the last piece to talk about with buyer acceptance is going to be cost. This is a difficult thing, and something that, while it can be overcome, if we want to electrify, we need to electrify for all people at all income levels. Currently, last I looked at it in the state of Colorado, heating with natural gas versus heating with electricity, BTU to BTU, electricity was about 6 times more expensive. That is mostly due to just the incredibly low cost of natural gas where we live. But being aware of that and trying to find opportunities to improve efficiency, reduce the number of BTUs, and then look at electrification will be the best option for these low income homeowners. So next poll. Let's see.
Yep, polls are open.
Yep. Keep this open for about a minute. Please, everyone, vote as much as you can. And love to see who out there has fully electrified a home.
Okay, that probably does the trick.
Yeah. Let's see. That's great to see. About 25% of our audience, almost 25%, has taken a home to full electrification. It seems like we've got a huge opportunity for everyone else out there to start exploring and seeing what options are available to them. And then for our builders in the room, if you wouldn't mind voting on if you are currently building 100% electric homes. All right. And similar results to before. More builders are building electric homes than the wider audience. That's great to see, but still opportunity to explore electrification. So this is another, Steve, can we go back to that last slide actually? If you all haven't seen, there is a questions bar. I would love if anybody's willing to share to put in any concerns that you have about electrification. And we'll talk about those at the end. All right, let's keep going, Steve. So when we look at some of the three big areas for applying electrification, really looking at heating, water heating and cooling within the home, cooking within the home. Three big opportunities to really identify ways to pull fossil fuel related equipment out of the home. The big one, while heat pumps are definitely more common in warmer climates, definitely looking at the chart that Steve showed at the beginning from EIA, where the Southeast is really leading, it makes sense. Their climates make it easy to apply a heat pump. Really, one of the things that we've needed in colder climates is heat pumps that will work for the cold temperatures that we are experiencing here. And really, not that this technology isn't fully developed, or not that we're not done developing, but there are a ton of brands and a ton of equipment on the market that is existing, ready, and available to be applied in colder climates. One of the great resources out there, Steve mentioned NEAP. They actually curate a very large spreadsheet of cold climate heat pumps and have a lot of great information about them, information that you wouldn't typically see on the AHRI website, information about their capacity at lower temperatures. And it's a great opportunity to identify if you've got a brand or a distributor that you're loyal to, go and identify the equipment that they should be able to acquire and stay within your brand. Next slide, please. Another piece that I think is going to be a big innovation and a big opportunity is heat pump water heaters. I was researching these, just getting a little bit of their history. The first patent for a heat pump water heater actually came out in 1935. So these are not that new. We look at these as brand new pieces of equipment. They have been improving over the years. They've gotten significantly quieter, and their recovery time has increased significantly. And really, one of the best things about newer heat pump water heaters is the fact that they're becoming Wi-Fi enabled and have the opportunity for grid connectivity. I saw a great presentation from the Department of Energy a little over a month and a half ago about some opportunities around grid connected water heaters, and really some standardization that's happening to allow these to be able to use to both prevent peak load, but also to shed load from the grid at times when there's not a demand. So there's really a big opportunity. And I think too, one of the big misconceptions and the big worries that we have about these pieces of equipment, if you're in a warm climate, being able to put this out in a garage or put it in a semi-conditioned basement where it can help cool and dehumidify that space and kind of semi-condition is great. But when we get to these colder climates where we are doing everything we can to keep as much heat in the home as we can during the winter, do we really want to start putting a piece of equipment that's going to make cool air during our winter months? And really, one of the pieces that we've seen, and that from talking with different manufacturers that I've seen, is that really that temperature drop is much lower than we expect, and much lower than would create a comfort issue. Now in a small space, it's gonna cool the room off, but really putting this in a mechanical room, the heat that's coming off of the furnace or a heat pump, any sort of air handler, is going to actually combat a lot of that and really prevent any comfort issues. The other piece that these pieces of equipment seem to be improving upon is their recovery time. Most of these water heaters also will have a backup electric resistance, so that you're trying to manage both efficiency with homeowner expectations, so that you're not going to end up with cold water in the tank. Next slide, please. The last piece is induction cooking. Really fascinating technology, using a magnet to heat up the pan directly rather than trying to heat up a electric resistance coil or use natural gas. Studies have shown that these pieces of equipment can transfer heat as high as 80% efficiently, whereas on a natural gas stove, you're looking maxing out at about 43% of the heat generated actually getting to the pan. Another very cool piece about these is that since they're using a magnet, the actual stove top itself is not heating up. You can see in the picture just a piece of ice being able to sit on top of the cooktop. So especially among families with young children, preventing any type of possible accidental burn situation would be a really big advantage for these. What we've found in the Denver market has really been helpful is some builders have started doing some demonstrations with these pieces of equipment. Not only the builders, but some of the appliance suppliers will do cooking demonstrations and allow people to come and see and use them hands-on. It's really gotten people a lot more excited about it. We're also seeing some changes in some of the food cooking shows where induction cooktops are starting to be used and people are getting excited about them. So I see this as a really big opportunity for implementing at that luxury feel without the use of gas.
Yeah, Nathan, one thing we didn't put in here could have in sort of scope. We're not talking in general about indoor air quality issues, but there's an indoor air quality component of electrification that we're not touching on at all in this presentation.
Yes, huge implication. I think the reduction in PM 2.5 alone is just astounding when you look at the difference between natural gas versus an induction cooktop. I would recommend reaching out to the team at Lawrence Berkeley National Lab. They have some fantastic resources about the indoor air quality improvements. So one of the areas where we're struggling to see a viable switch at this point in time really comes to fireplaces. These are a luxury appliance and not something that buyers really need to operate their home, but especially in the Colorado market, it's a huge opportunity for builders to differentiate and attract and sell higher end homes. However, I have seen there are some all-electric fireplaces coming onto the market that don't look like the cheesy cloth waving in the wind. And in fact, one of our home builders clients is going to be showcasing an all-electric fireplace in one of their new townhome models. So would love to update and show everybody a picture of it in operation, but unfortunately that is not the case right now.
Okay, we're really close to the end here. Basically, we're at the end, but I'd be remiss without offering some thanks, in particular to Nate Adams, the House Whisperer, Electrify Everything. Nate has a really wonderful repository of resources that he's gathered into one handy place, so I highly recommend looking Nate up and finding his site and looking what he's got there. We already mentioned NEEP a couple of times. Thanks for the work that they're doing. There were charts from NREL, LBNL, RMI, and EPRI, and some others, and there's tons of stuff. So really thank you very much to the people who are out there in the front lines doing the research that is paving the way for our understanding of how we can make this all happen. And thank you to my partner Nathan there in doing this, this brave new world that we're in. Nathan's back home in Tennessee, I'm here in Colorado, and you all are out there, and there are a lot of questions, and so we will do this for a while. Mike, how do you want to deal with them?
Well, you are exactly right. There are a lot of questions, and that's great. We love to see them. And in fact, I've just put out a call now, both verbally and to everyone via typing it in, that send in your questions via the questions box. We're going to start going through them, and so everybody just kind of settle in, because we've got great questions, and I know our guests are eager to answer them. So first, we're going to ask a question to Nathan. Given your experience working with builders, do you hear about any customer pushback on cooking with electric versus gas? One of our guests or attendees here, Joel, mentioned that there's a time delay sometimes when cooking on ranges. So can you talk a little bit about that?
Yeah, absolutely. When you're looking at, traditional electric resistance coil, there's always going to be that delay. I'll just share, as part of my background, not only am I a part of the building science industry, but I grew up in a kitchen. My dad is a professional chef, and I grew up with a gas stove in the house, and I love it. Love cooking on it. And really, that's what we're hoping that induction is going to help solve. It has a lot higher control than a typical electric resistance coil, and I've cooked on them and have actually found that I prefer it to natural gas. I can get a higher temperature control and a lot more, a lot better food coming out of the kitchen with it.
Yeah, I think that's a common misconception that people don't understand the difference between induction and electric coil. There's education need there. I think it's really exciting that builders are, what a great opportunity for builders, not just to demonstrate magnetic induction, but to do something really cool in terms of, hey, let's cook in a show home. That's a great opportunity in a variety of ways.
Mm-hmm.
All right. And a follow-up question, any questions about the cost of induction?
Yeah, so Nathan here, when I first started looking at these probably 3 years ago, there was a pretty significant cost add between natural gas and induction. But in the last 3 years, the cost for induction has come down pretty significantly. And I'm seeing like slide-in induction stoves that are maybe $200 to $300 more expensive than a natural gas stove. And of course, that's going to vary by brand. If you are installing a cooktop, those are going to be a little higher cost difference, but not as significant as it used to be. I think last I saw, you could get a, I don't know if it was a Whirlpool or a Samsung 4-burner stove with an oven that I think had 2 induction coils and 2 electric resistant coils, and it was right around $1,200.
Yeah, I saw some indication that they're coming below $1,000 now too.
Yep.
Okay. And I want to make sure, just before we get to the other questions for our attendees, here at the webinar series, unless our presenters have a hard stop at the top of the hour, we do get to every question. So rest assured, we are going to get to your questions, because we did ask Steve and Nathan prior to this if they had to stop right at the top of the hour. They do not. So we're going to make sure to get to all of your questions. So please keep them coming in. No, we are going to get to them. We have a question from Bill S. Can you address the topic of natural gas distribution leakage? He had a question about that early on in the webinar.
There's some questions that inevitably we're going to have to punt on, Mike. I know there's an issue. I know that I did not touch on what would also be a small trend, which is the banning of new gas infrastructure, in particular to new build communities. There, Berkeley, Arlington, Massachusetts, which was also from the NEEP webinar yesterday. A handful of other communities around the country banned new natural gas infrastructure to new builds, and in some cases to gut level or deep retrofit. So I know that may not be quite the question that's being asked as far as like gas, leakage out of the gas infrastructure. I'm not an expert. I don't know anything about how much there is. I know there's some, but I don't know anything about that. Maybe if somebody out there knows something, they can pop it in as a question, if you will, but a response, and we can get that out.
Well, and Steve, I would say all of the research I see on natural gas leakage is that it's consistently higher than previously reported.
Yeah, I've seen that too. Yep.
Okay.
And there's been a lot of questions, in the brief research, and I will claim no expertise on this. There's been a lot of questions coming up about what can be done with that natural gas infrastructure after electrification. It's some really interesting opportunities. Seen one proposal about could this be a source for hydrogen distribution across the country as well.
Okay. Next question we had was from Carlos. He wanted to know, what is the additional cost to upgrade the electric service panel?
Yeah. Well, and so it's not going to just be the cost of upgrading the panel. Really depends on what the service itself looks like. And in new construction, we have it pretty easy that we can make these changes on paper and plan for it. And so going from 150 amp to a 200 amp service, really, we were looking at a $400 or $500 cost add, but in existing homes, if you're having to bring in and replace a service from the street, that I can see being over $1,000, but that's about as close as I can get.
There's a couple of good case studies on Nate's site about that, where the cost, can get quite extensive if you have to go to the street, for sure.
Okay. And some people are chiming in about different leakage percentages in their areas. I'm seeing 2 and 5%. Just to throw that out as a reference to some of our other attendees that are here. I do want to move on to another question though, and that is our friend Jim mentioned that Rheem makes a 15 amp heat pump water heater. It's still 240 volt, but it's only a 15 amp 240 volt. It frees up some panel space. He says the recovery rate is not as fast, but it's nearly the rate of a 30 amp system. Richard then chimed in also that there are a number of heat pump water heaters in the 3.4 to 3.5 UEF COP range. So I want to make sure that information was shared.
Yes.
Absolutely.
Jesse's concerned about the long-term cost for the customer, because that's a question that he's going to have to answer. So can we talk a little bit? I mean, we've been talking about costs a little bit, but can we talk about long-term costs for customers?
Yeah, it's obviously that's one of the big regional variables. Our natural gas costs are incredibly low here. There's so as we move, the portfolio away from coal towards natural gas, it depends on the utility, their portfolio mix, what that's going to look like. For us here, it's going to still be cheap. Electricity is not expensive here. Gas is even less expensive. We're right here where a lot of it's produced, so there's a distribution component of that. If you're in the Northeast, that's a different picture. The long term, to me, that's a really tricky question, because people who are in the business of projecting longer term consumer end pricing, boy, that's a tough game. Nathan, do you have anything on that?
Yeah, I can really only speak to the Colorado market and pricing that I've seen. We've definitely seen, and it's very much specific to our market and what's going on there, that heating and water heating with electricity will cost more. I think really at this point it's trying to understand, can you find opportunities around financing to include solar with either a retrofit or a new construction that will really eliminate a lot of those long-term cost pieces. Being able to offset your heating costs with solar is fantastic, and something that you cannot do with natural gas.
Yeah. Well, and then harkening back to something I mentioned earlier, where you said rate structures can have a big impact on how viable this is, depending where you are, and that's definitely true. So, what are the time of use implications? I mean, is the utility got peak shaving opportunities by pushing things to electric? There's all kinds of, because they'd have more control over end use, all kinds of implications about that. I think the real answer is it is case by case, utility by utility.
And Jennifer brings up that the installation of solar panels can offset the concern about electrical costs going up, and I can certainly vouch for that myself. That's one of the many reasons why we have panels on our roof here.
Mm-hmm. Absolutely.
I did have a question from, from Margaret. She goes, well, what about standards? Energy Star doesn't do double ovens, and she attended EBA, and there was a discussion there that about dryers and creating a huge load all at once, and that presents a little bit of a challenge. Can you guys talk a little bit about that?
I'm not completely sure I understand the context of the question. What do you think, Nathan?
So as far as grid impacts around electric dryers, it's absolutely a concern. being, if everyone came home at 6 o'clock in the afternoon and decided the first thing that they wanted to do is turn on their dryer, you would see a massive spike. Fortunately, that's not the reality that we see. And fortunately, there seems to be a broader implementation of condensing dryers as well that are going to reduce that electric consumption. And so as those become more cost effective and get broader market acceptance, I think the question about electric dryers tends to go away. The other piece that we're seeing, and this is coming from friends at NREL, that working on communication around these different appliances and being able to communicate directly to a buyer when they're saying, not that the utility will stop them from starting their dryer, but say, hey, we're at a high demand point in time. You can start your dryer. It may cost you this much more, or you have an opportunity to save money by using the dryer at this point in time as a way to reduce that grid impact. So there's work being done and research being done and potential products out there to help eliminate that concern.
Yeah, I think I can weigh in on the first part of the question. It's absolutely true that there are limitations in both the HERS rating protocols and in Energy Star for capturing things like double ovens or second, third refrigerators and stuff like that. That's completely valid.
Okay. And I want to also interject something here. We have a lot of smart people who attend these, and we certainly welcome their questions and their comments. And one thing that was shared with me here via the questions box was something from Kavita, who is citing a study from E3 in California. Or I should say there's a study done in California by E3 that concluded that building electrification would deliver life cycle cost savings for most home types in the study area. And in fact, homes with air conditioning, the economics are particularly strong. And she goes on to talk a lot more too, but I just want to make sure to interject the main headline of that, which is, hey, this is it makes economic sense. Even homes without air conditioning, it's a little bit more of a mixed bag, but it's still, in total, it looks to be life cycle cost savings there.
That's great. Appreciate that.
So Vincent had a very specific question, and I don't know if you guys may or may not be able to address this, but I told him I would ask you. He wanted to know what percentage of impact on carbon emissions will electrification in new construction have in the Northeast? Now, again, a very specific question, and maybe we take this a little bit more broadly, but what's the forecast showing as far as impact on carbon emissions if we do go this way?
Yeah, I can't disaggregate the answer to the Northeast, and I can't disaggregate it on new construction either. I don't know if that data is out there. I'm sure it's out there somewhere, but it would be buried a little bit. So sorry, I can't answer it. Other than to point back to the 10% of carbon emissions for the country, but that's on all buildings for space and water, for space heating and water heating. So that doesn't help a lot, I realize, but maybe somebody else has. I don't know if anybody from NEEP is on the call. Maybe somebody from NEEP knows the answer to that. And if they don't, if nobody is, that's where I would go to get the answer. If it were me, I'd go to NEEP.
Sure. That's a very good reference too. It's a good organization, does some good things up there. I want to move on because, like I said, we do have many questions. I want to get to them all. Bill S., he wanted to know if a link is available, speaking of NEEP, to the NEEP spreadsheet that curates cold climate heat pump capacities that Nathan mentioned. Is that available?
I put up the NEEP general one, neep.org. That one's easy. Nathan, would you mind rounding that up? Because I didn't pull that in, and you can send it to Mike, and Mike can push it out to everybody.
That'd be great. We do have a question from, and I apologize if I butcher your name, Vishwas. The question is, I think it's really specific to Energy Logic. Do you focus on builders, installers, or do you also engage with homeowners directly on building electrification?
So our primary business is around new construction and home builders, Front Range of Colorado. So that's our focus. So we're actively engaged with all of our builder partners in, bringing them whatever we think that they're interested in, we think they should be interested in. So we bring it up. It depends. It's like knowing your clients. There are certain clients of ours that we know would be interested in it and would have an open ear. Nathan's part of our biz dev team. Do you want to jump in on that one?
Yeah, absolutely. I think really our goal is to try to engage builders where they are and find them opportunities that are going to meet their needs and keep them moving forward. So of course there are production builders that we work with who I'm not going to name, that they are not ready for electrification, but there are absolutely builders in the Colorado region that we're working with that are strongly investigating it and working on it. Another piece that I've seen that I find actually interesting is in the a single family home rental market. I see a lot more all electric communities coming through that market.
Yeah, and that makes sense, because if you are a builder that's actually building to hold on to it and rent them, then the implications of having a simpler home that doesn't have natural gas infrastructure, doesn't have the maintenance issues that you'll have around having gas in the home, that just makes more sense. And like any market, I think you're going to get early adopters, and our large production home builders do amazing work, but they're going to follow the envelope pushing builders, no pun intended.
Okay. Another question that we've got is, how does electrification affect home buyers who want to use radiant heat in the floor?
Ooh.
Yeah, I would say that it's still possible. Geothermal equipment is probably going to be best equipped to support that right now, but I have seen from several air source heat pump manufacturers that they have equipment for a air to water heat pump. I will say, unfortunately, a lot of those manufacturers, they're making that equipment overseas, and it is not yet available in the US. It's available in Asian and European markets, but not in the US currently. And I think as demand for electric radiant heat continues, there will be more demand. I would strongly advise against electric resistance radiant heat.
Right, that's what I was wondering. That was the question. I would agree with Nathan. Anecdotally, if you've ever been in a home, and radiant floor, I've never been in a home with radiant, direct radiant, I guess we call it, resistance heat in the floor, but I've been in one with radiant resistant heat in the ceiling. It was possibly the most uncomfortable place I've ever been.
Mm-hmm.
Okay. Yep. Got a couple questions from our friend Eric, and I'm going to take one of them now. Is the current HVAC market capable of shifting from gas furnaces to heat pumps, or is this going to require a large shift in capabilities?
That's an interesting question. What do you think, Nathan?
So I will say there's definitely a need for training and a need for reskilling. And I would say that I've seen HVAC contractors address it head on and decide that that's the market that they want to be in and they want to get out of gas, and they are doing well and successful in just doing air source heat pump or geothermal work. But I will say, a lot of the HVAC techs are most comfortable with traditional equipment, and they will need training to get the skills to continue to be successful as electrification continues on.
Yeah, and there's good work being done by manufacturers. I think Nathan's hit the nail on the head with his comments there. The manufacturers are doing good work and probably need to do more on that topic.
Yep, and I would say another group that I've seen from both a technical and a sales aspect that is doing some good work would be HVAC 2.0. Again, another group led by Nate Adams doing some fantastic work.
All right. We've talked a lot about needs in the Northeast, and just so that others don't get jealous, we're going to take some questions about some other parts of the country. And so actually, we're going to start with a comment. This was sent in by Mike, and he's down in Georgia. And he feels a stronger case can be made for all electric new homes, but he struggles because with this being a recommendation for existing homes. And where he cites is in Georgia, they have deregulated gas. So there's a hefty monthly meter fee, but they have really low therm rates. And so he says it makes economic sense to either be all electric and avoid the meter fee, or use gas for everything that you would normally use gas for. So he says new homes can have significantly improved envelopes, which enable heat pumps to perform well, but for existing homes, it becomes a lot more challenging to use or even encourage an air source heat pump if you have a not so great envelope and you have iffy ductwork.
Yeah, I concur, and the literature supports that, experience supports that. Go back to saying, we didn't focus on envelopes, but it's, to me, it's been something that I was trained in. Maybe it's changed a bit, but I don't think it has. When you talk about really crappy houses with bad envelopes, one of the only really good solutions, if you're not going to deal with the envelope, is to go to a ground source heat pump. That's when they can make the most sense from a ROI perspective. I'm sure there's lots of debate, for sure. We can all agree to disagree on certain things. But if you're going to come into poor envelope situations with low temp, delivery air, that you're asking for problems, and you're not going to get where we wanted to get. So I agree with that entire statement. I do think that there's a segment of the buying public that will entertain deep energy retrofits, and this is part of what Nate's doing his work on in Ohio, where you got a different climate, to be sure. So doing what Nate does in Ohio and replicating in Georgia is a heavier lift. But there's a segment that will do that because they're trying to lead the way from a climate perspective. Nathan, you want to chime in?
Yeah, I think we advocate this in new construction, and I think it's even more important in existing construction that the house is a system, and understanding all of how the house operates, and knowing that, yes, making that switch to electrification will also require building envelope improvements to be successful, or you're just going to end up with an unhappy homeowner. I think is really the key piece there.
Yeah, and that's true whether you're electrifying or not. If you come in and just think you wave a magic wand with tech on bad envelope houses and get comfort, that's generally foolishness.
Okay, and the mention of the ground source heat pump might be in a lead into the question that Eric asked, which is Should heat pumps in cold climates, let's say Minnesota, should they include electric backup when outdoor temperatures can be below 0 for a few weeks in a row?
My general impression is they don't have to. They often will have them anyway. They don't have to. And the performance that we're seeing out of the units, that we highlighted there from Carrier, from Mitsubishi, the performance at really cold temps is astonishing. And I'll reference to not this winter that we're just ending now, but winter before last, when we had the incredible cold snap wave, front that came through in Chicago in particular. And and this is in talking directly to friends at Mitsubishi and at Carrier, with thousands of many split systems out there, and no calls, not a single call. One that they determined that was not the unit's problem, actually. So both the anecdotal and the specification evidence is there to suggest that it can be done. Again, let's go back to the envelope. If we're talking new construction, I would go there. If we're talking, retrofit, maybe not. Nathan?
I would echo Steve's comments. I think too, we did some looking for a local builder in Colorado that is doing an all electric community, and really, we felt like the system was undersized, that they were asking for in our HVAC design and our manual J we're looking at. We feel it was undersized. And if your third-party designer is telling you it's undersized, and with people who are pushing for the smallest equipment possible, then it's probably undersized. But really, we kind of ran the math and said, okay, what happens really? We assumed, or he was asking us to assume a design temp that was, I think it was something like 5 degrees warmer than the actual design temp. Very educated contractor that we were working with, and really trying to run the math on how often the electric resistance was going to be used and what that energy penalty would be, was actually very minimal. So,
yeah,
yes, can the equipment do it? Absolutely. If we are designing designing and installing appropriately, I think our reliance on that electric resistance backup is going to be fairly small.
So we have a guest who's attending this named Ron, and he took umbrage with something that you guys mentioned earlier, saying that heat pumps leverage electric 3 times the input or more compared to gas, which can be 95% efficient at best. So saying electric is 6 times more than gas, he feels is not a very fair comparison. You want to respond to that?
My response to that would be it's the physics. Do the pieces of equipment work differently? Absolutely. But BTU to BTU, how heat pump technology works is not to create heat, but to move heat. And that's why we are able to be that much more efficient.
Gotcha. All right, scrolling down here, because we have some great questions coming in. We have a question from my friend Frank. He wants to, he mentioned that builders and developers should be focused on net zero energy homes and or developments. This would seem to be a much easier sell and overcomes issues with grid energy costs. It really just becomes a question of ROI, not cost. But he was looking for your comments on that.
I think I agree if I understand the comment.
Yeah, I think he's looking at more, but just look at net zero as opposed to how you do it.
Oh, is this
Yeah.
simple? Yes, go ahead. Go ahead, Nathan. Yeah.
Yeah, I mean, I would say that going all electric simplifies net zero. They're very complementary to each other.
Yep.
And the fact that you are running 1 meter to, or depending on your utility area and what's going on, possibly 2 meters, but only one service, one utility to both account for your consumption and production makes it very simple. And I agree the look at the ROI is important. I will say that the typical home buyer is not going to that jazzed about ROI. And so when I was working for a builder, one of the tactics we used and we found to be most effective when looking at net zero homes was based on our design and our experience, our math was pretty much to get to net zero, you're going to have to spend about $100 more a month on your mortgage. It costs more to build a better home, but compared to your previous home, compared to an existing home, or if you're familiar with the HERS score, a home that has a HERS score of 100 or 120 actually, you will be saving about $300 a month compared to that. So you give me $100, I'll give you $300 in savings. You're netting $200 every month. That's a real easy conversation to have, and a real easy way to get them to fully understand the value of net zero. And while 200 may seem small in the grand scheme of things, that money adds up. You know, I think over the life of a 30-year mortgage, that $200 a month, it's over $100,000. So we would put it in terms of, you know, is that your child's education? Is that your trip to Europe? Is that your Ferrari? Is that your, it's whatever you want it to be, but it's money that you wouldn't have had and now you do.
Can I have a yacht? Is that okay?
Small
I'm just kidding. No, we also have a question from Kelsey. She wanted to know, in what capacity do your organizations or others work with or participate in the International Code Council's electrical code? And how has electrification been used in code updates?
I will say we typically
Go ahead.
Yeah, sorry, Steve. I'd say we stick to the energy code rather than the electrical code.
Mm-hmm.
We are energy people, not electricians. Is that something that I strongly believe that heat pump manufacturers, especially those that are doing variable speed or variable compressor equipment, should be a part of those conversations and understanding how to properly size your service with that piece of equipment versus a typical single speed compressor, I think is very important.
Well, if I could, gentlemen, I guess I'll add in a little bit on this topic, and that is that specific to the energy code, Kelsey, the 2021 IECC was debated and discussed throughout 2019, voted on at the end of 2019. Voting results have not been officially finalized by the ICC, but the preliminary results and some additional subsequent reporting has shown that there will be electrification updates incorporated into the 2021 IECC. So we will be seeing that coming out in the most current version of the Energy Conservation Code. And so then it will come down to where do the states adopt it, or where do localities, municipalities, and smaller jurisdictions in the state level where do they adopt it and how do they adopt it? Because each of those entities, whether it be a state or a municipality, does retain the right to amend the model code. So this is certainly something that we have seen arrive into the IECC. The question will be, what does it look like when it comes to implementation of it? Wanted to share an observation real quick from Stephen, going back to when we were talking about carbon emissions for new construction. His comment is that the vast amount of emissions come from existing buildings. However, every new building constructed with gas is more gas infrastructure built that will continue to be emitting for decades. All electric new construction, at least from an emissions perspective, is about us stopping making the problem worse. So that was Stephen's observation there.
Yeah.
Some people might be feeling a little hungry. There's a question about stoves. We're going to go back to stoves for a minute. Hugo asked on the magnetic induction stoves. Now he's heard that specialized pots are required, and if they are damaged at all, they're expensive to replace. Is there any way that regular steel pots for cooking actually work on the magnetic induction stoves?
Yeah.
Go ahead, Nathan.
Yeah, anything that is magnetic, I've found a little fridge magnet that I actually just took around the store with me when I bought my last pot, and it was just a normal pot from Target. It works very well. Another piece that works well is actually, the old cast iron.
Yep.
Anything that will conduct magnetic, it works just fine on there.
You can stick a magnet to it, it works, and really flat bottoms work best because of the surface contact.
Okay, great. Wanted to get to a question from Patricia. She wanted to know, how are contractors responding and or embracing these new electrification mechanicals and appliances for builders? And this is talking about the installation of them. What percentage of contractors are actually installing heat pumps and other electric equipment options?
So I would say of all of the builders that we work with, and that ends up that in the Colorado area, we work with, I'd say probably 5 main HVAC contractors that handle a lot of the work. These are bigger companies geared up to do production work. All of those companies have techs that are trained to do heat pump work and that do it regularly. It's not the biggest portion of their business, but they all have the capacity and the capability. And I think as demand grows, they will continue to train and build up their workforce to continue to grow that as well. I mean, Steve, would you say the same?
Yeah, and the trades are going to respond to what the builders need, and the builders are responding to what the consumer wants by and large, except for those builders that try to push things in new directions to differentiate themselves.
Yeah.
Going to go back up to the Northeast for just a minute, guys, for just an observation from Alvaro. He said that it's been said there that electric bills are higher with electric heating, but in New York, we have found, and this is him saying this, that the utility bills are lower with heat pumps. So just to share that as part of the discussion here. Bill S. had sent in a question asking for any advice, or do you guys have any experience on heat pump clothes dryers? Anything you can share on that topic?
I know nothing.
I mean, I've looked at those as well. Working for a fairly progressive builder, we were a little concerned about constantly putting a 4-inch hole to the outside of the home for just our dryer. That just due to some of the code restrictions, that tends to be a pretty leaky hole. what we had found is they're on the market, they're available. I don't think they're going to meet quite the smell test for most home buyers at this point in time. They just take a little bit longer. But what's interesting, I'm trying to think if it was Oak Ridge National Lab or just a DOE project in general. They've been working on different different dryer designs, one of them being a dryer that vibrates the clothes rather than heating it, and shows huge efficiencies and operates at about the same speed as a typical, electric or gas dryer.
Interesting.
I know I've got more questions. Here's another one. From Eric. He wanted to know about, we were talking about cost differences earlier, and so he wanted to know, what is the cost difference between a natural gas stove versus induction?
Going to take that again, Nathan?
Yeah. One second. What I've seen is that a slide-in stove, you're talking $200 to $300 cost difference between gas versus an induction. When it comes to stovetops, maybe closer to $800 difference.
Okay. We had two mentions in they were sent in via the questions box, one from Richard and one from Stephen, mentioning air-to-water heat pumps. You guys want to talk a little bit about air-to-water heat pumps?
Yeah, are they talking about water source or air-to-water distribution? Like, to me, that's, Nathan, what do you think?
Yeah, I mean, I've seen examples of both. As a air source heat pump that uses a liquid for distribution. There are plenty of examples out there, and actually some really big jumps being made in CO2 heat pumps, where it's CO2 rather than the 410A is the refrigerant. Get some really big improvement in colder climates. Their COP is a little bit bigger than a typical air-to-air heat pump. And then there's also examples of using water as your heat sink or source, similar to geothermal using the earth. So I'm both are available. I mean, I would say, call all of the manufacturers and tell them that the products that they're making that are readily available in Europe need to also be available in the US, and we will have a lot more examples of them.
Yeah, that's Europe or Asia. Lots of product there that we don't have access to.
Wow, that's a shame. I want to throw out a final call for questions. Appreciate all the questions that have come in, everybody for attending and sticking around. I do have another one here from Lynn, and the question is, can you address small house electric systems that are not going to do air source? So they might be, a small house that's got an oil-filled electric baseboard, co-radiant versus straight resistance baseboard or not. So it's kind of just the question is, what about these small home systems?
Mm-hmm. So if I understand the question, we're saying like they're not going to do a heat pump that's just for whatever reason that's off the table.
Apparently so. Apparently
okay.
so.
Well, I mean, if you're going to use resistance, which is what it seems the question is asking, then the focus is all on the shell. All the effort then is going to the shell, because resistance is is what resistance is. You can't change the nature of it per se, and it'll still be electric, but it could be, it depends on what the resistance is. It could be quite expensive, but if you tighten the shell down enough, then electric resistance can still work nicely and doesn't even have to necessarily be expensive. Small house, super tight, it can be done. What do you think, Nathan?
Yeah, I'd agree with that. I think another possibility that maybe is looked down upon because of people's experiences with them, but instead of maybe looking at a mini split, looking at a PTAC or a VTAC unit, they've come a long way, and they're pretty affordable and can fit into that small house model very well. You know, there's a developer in the Denver area that is doing multifamily housing, but doing it modular, and so building everything. You know, these are 700 square foot modules that he's doing, and they're using VTAC units as their main source of heating and cooling, and seems to be working very well for them, and they're getting some really good energy performance out of those units.
Excellent.
All right. Well, I don't see any other questions, gentlemen, so I will go ahead and call it there, but I got to make sure to thank both of you for sharing your time and your knowledge with us today, and I am pretty sure, I'll have to check with Mary on this one, but I'm pretty sure you are now the record holder for most questions in a Q&A. You beat out the esteemed and infamous Joe Stiebrick on that one, so congratulations, gentlemen. Way to go.
Well, thanks. It was fun. I appreciate all the questions. Absolutely.
Yeah, no, it was a blast. Oh, sorry, Nathan, didn't mean to cut you off there.
Oh, I was just going to say thank you all for the great questions and being engaged.
Yeah, no, it was great, and we thank that audience so much. I know everybody's at home and they're attending webinars and that, but we really appreciate you carving out some time out of your day to attend this one. You probably got a number of options, and we're glad you chose us. And thank you too to NV Energy for their generous sponsorship of this webinar. And if you had fun on this one, guess what? We're going to be back in 2 weeks. That's right. It would have been tax day. It's Wednesday, April 15th. We're going to be here at 2 p.m. Eastern. We're going to welcome Sam Rashkin. He's going to make his webinar series debut, and he's going to demystify zero for us. So make sure you join us. Until next time, stay safe, stay healthy, and take care of yourself and your family. So long.